Okay, so we were looking at counting, and after that, so basically, 1 minute. So we were looking at counting. So basically, today we are going to look at permutation combination. I think you know these things already, probably, but in different perspective, Uh, in fact, towards the end, I will show you how certain, for example, Pascal identity. Pascal identity, and choose something, and then those kind of results can be done just by merely counting argument. You can prove them. Okay. Otherwise, you use factorial formula, right? And choose k is equal to factorial n divided by factorial k into factorial n minus k. Remember those things? NCR or n choose k, right? So, so that's kind of combination. So basically, let me show you. First of all, I am going to talk about permutation. So I'm going to start with this question. In how many ways we select 3 students from a group of 5 students in line for a picture. The question is, in how many ways we select 3 students from a group of 5 students? So we have a group of 5 students. So I'm going to sort of make it here. Okay. I have to choose these 3 places in order to make a line. So 3 students have to choose. Total number of students are 5. First student can be chosen in 5 ways. Once this is chosen, one student is less. So now this can be done in 4 ways, and this can be done in 3 ways. This can be chosen in 5 ways. This can be chosen in 4 ways, and this can be chosen in 3 ways. So total number of choices are, number of ways, 5 into 4 into 3 is equal to 60. Okay. So what we are doing basically, this is kind of a permutation. I want them in a specific order. From a set, I want to select certain objects in a specific order, right? This is ordered. That's why it's known as permutation. So let me give you a formal definition of this. What is permutation? So a permutation of a set of distinct objects in an ordered arrangement. This ordered word is important. Of these objects. Okay. So a permutation of a set of distinct objects is an ordered arrangement of these objects, right? So basically, if I take set to be S is equal to 1, 2, 3, So 3, 1, 2 is a permutation, right? Then one order, third, then first, then second. This is one order, right? By the way, how many permutations are possible? 3 factorial. Very good. So now I think if I say 3 and 2, this is also a permutation. The only thing is here the length is 3, here the length is 2. So we call it as a 2 permutation. Okay. So in general, if the elements are R, we call it as a R permutation. Okay. So basically, out of n objects, if you are selecting R objects in an order arrangements, that can be done in n, n minus 1, n minus 2, dot dot dot, n minus R plus 1. 1 less than equal to R less than equal to n. N is a positive integer. So this is the formula. Product of, so the first thing can be chosen in n ways, second can be chosen in n minus 1 ways, and so on. If I have to select R, right? So this is the general formula. Whatever we have done, shown in the previous example. So n into n minus 1 into n minus 2 up to n minus R plus 1. Right? So this is we denote it by PNR. R permutation of a set of n objects. So clearly, I mean, you can, from this algebraic identity, you can check that Pn0 is 1 and Pnr is nothing but factorial n divided by factorial n minus R. So less than equal to R less than equal to n. Do you agree? By including 0, and then by that convention, we have this formula that PNR is equal to factorial n divided by factorial n minus R. You can open the factorials and see it is n minus 1, n minus 2 up to n minus R plus 1. Now we come to another concept, combination, or I will call it as R combination. So let me take another example now. So suppose we take a set S to be A, B, C, D. Okay. And if I ask you, write down the subsets of size 2, right? Or possibilities. So, or combinations of 2 elements. So out of 4 elements total, I have to choose 2 elements, right? So what are the 2 elements? 6 subsets are possible, I would say. A comma B, A comma C, A comma D, B comma C, B comma D, and C comma, right? So in other words, I say that this is n is here 4, choose 2, or 4C2, right? That is the notation. Out of 4 elements, I am choosing 2 elements. So 4 choose 2, right? You know this formula is what? Factorial 4 divided by factorial 2 into factorial 4 minus 2, right? But you can prove that thing also very easily, you know. I'll just establish just one line proof. Okay. So this is a combination. Previous thing was permutation. So in permutation, there is a ordered arrangement of objects, right? This is there is no order here. You know, we are just selecting. Okay. Out of n elements, we are selecting R elements. Okay. And how many ways we can choose? And choose R. I mean that's a very simple thing, right? So we know that we have this formula that n choose R, or I would say that there is a theorem that the number of R combinations of a set with n elements, we denote it by n choose R or C n R, and actually this value is factorial n divided by factorial R into factorial n minus R. where 0 is less than equal to r is less than equal to n. So I have need to prove this fact that number of r combinations of a set with n elements. N elements are there. I have to find out r combinations. How many of them will be there? N choose r, right? Or CNR. So I mean the proof is one line, and so I'm just writing the one line, right? Note that the r permutation of the set can be obtained. So from these n elements, r permutation, if I permutation means order arrangement, right? Can be obtained forming the CNR R combinations, and then ordering the elements in each R combination. So what I'm saying that R permutation of the set can be obtained. R permutation. N objects are there. R permutation of the set can be obtained by forming the CNR R combination, right? R combination is all subsets are गए R के, right? Size के, and then ordering in each of them, right? Then ordering the elements in each R combination. ठीक है ना? जो भी subsets आए उसमें फिर ordering करेंगे, right? So that is basically, that means we have P and R is equal to CNR times PRR, because ये ordering के लिए in each subset we will require this much, right? This is the total number of A. So that means I can find out what is the value of CNR from here. So that means CNR is equal to PNR divided by PRR is equal to factorial n divided by factorial n minus r divided by factorial r divided by factorial r minus r, which is simplification will give you factorial n factorial r factorial n minus r, right? This is the formula of R combination. So remember, R permutation ordered arrangement hai, right? It's an ordered arrangement, and combination we are just getting all the possibilities, right? Okay, fine. So this is all about permutation combination. Okay, one simple thing I can mention about, you might have seen this formula, x plus y raised to power n is equal to summation j is equal to 0 to n choose j, x raised to power n minus j, and y raised to power j. Remember? High school में पढ़ा होगा शायद पहले. So how do we prove it? By counting arguments, So that is what is the important thing. So it's very simple actually. So the terms are, I can mention that terms are x raised to power n minus j and y raised to power j, right? N minus j and y raised to power j. So to count the number of terms, I need to count number of terms of this form in the expression, right? How to count that? So x can be chosen. So total sum is what? N. N minus j plus j is n, right? Total sum is n. I have to choose n minus j x. So basically what will be there? In how many ways I can choose? Choose n minus j x from the n sum, and this can be done in n choose n minus j ways. N sum में से n minus j choose करें, right? So the other j term in the product are y's. So so basically that will be settled automatically, and this quantity is nothing but n choose j. So We are done the proof. That's about binomial coefficient expansion. So I think that is very simple. I'm going to now do one Pascal identity and just observe. In fact, I'll do two identities. Just observe their proof. It's very, by counting, I have to establish the identity rather than doing this factorial business and expanding. Okay, just by counting. Okay. So, by the way, this identity is known as Pascal identity, but this was known in India a long time ago, right? So it is an exercise for you to find out who discovered this. N and K are positive integers, and with N is greater than or equal to K. That plus means positive integers, right? Then I have to prove that N plus 1 choose K is equal to N choose K minus 1 plus N choose K. Right? ये तो पढ़ा ही होगा हाई स्कूल में. Because you people are from JEE background, right? So this is easy for you. Okay. So actually, rather than proving this, just for the simplification, so just for the simplification, we are going to prove something different. I'll say that I'll prove N choose K is equal to N minus 1 K minus 1 plus N minus 1 K. I have just replaced N plus 1 by N minus 1, right? I'll prove this. थोड़ा आसान पड़ता है, but anyway, the arguments can be done in another way. So what is N choose K? Now observe it carefully, just pay attention. It's very, very simple, but so N choose K is number of subsets with K elements from a set of N elements, right? That is by definition. N choose K, number of subsets with K elements from a set of N elements, right? K elements का subsets pick up कर सकते हैं. Now, this can also be done in another way. To suppose A is an arbitrary element in set T. I call this set as T, which is having n elements, okay? And I pick up one arbitrary element A from this set T, right? Now, when we are trying to construct K subsets, when we want to construct a subset of K elements, either this A will belong to that or it will not belong, right? If I have picked up an arbitrary element A from the set T, which is having n elements, now I am forming K subsets, right? So basically, whenever I am forming subsets, either this element A will belong to that subset or it will not belong to subset, right? So now what I am going to do, to construct a subset of K elements containing A. So that means out of n elements, I have to construct a set with K elements, and A, small a element which I have chosen earlier, is part of this K subset, right? So that means choose A and K minus 1. एक कम हो गया ना K में से, K minus 1 elements from the remaining n minus 1 elements. I can choose anything. क्योंकि उसमें से A निकाल लिया है n T में से भी, right? Okay. And so this can be done in n minus 1 choose K minus 1 ways. Agree? This can be done in n minus 1 choose K minus 1 ways. Fine. The second way is to construct a subset of K elements not containing A. Now I have to construct a K subset where A is not a member. Okay. So this can be done. Now since A is taken out from T, right? So this can be done in how many ways? So K elements I have to choose from the remaining n minus 1 elements, right? Remaining n minus 1 elements, because A is not part, right? So this can be done in what? N minus choose, n minus 1 choose K ways, right? So that means when we combine these two things, so every subset of every K subset, every subset of K elements from a set of n elements will either have A or it will not have A, right? So it is kindly basic. So basically, it is the sum of these two things. So that this implies that n minus 1 choose K minus 1 plus n minus 1 choose K is equal to n choose K. Right? Got it? It's very simple observation. जेई की कोचिंग में गए होते तो वो फैक्टोरियल से सिखाते, राइट? So here there is no JEE coaching, so you have to learn different technique, right? These counting arguments are very important. So just by counting, you are able to prove the things. Let me establish one more identity. Vendor Mohs identity. Again, M, N, and R are non-negative integers. What word? Vendor Mohs identity. Okay. Vendor mode का नाम नहीं सुना है? एग्जाम में सुन लोगे. Vendor Mohs inequality. Identity actually. Sorry. He was a very good mathematician. I love him because he has done beautiful things, and beautiful things I like. So you may get some beautiful things somewhere, right? Okay. And R is, not exceeding either M or N, right? So the result is M plus N choose R is equal to summation K is equal to 0 to R, M choose R minus K, N choose K. I think ये line बार बार आ जाती है, but anyway, M plus N choose R is equal to summation K is equal to 0 to R, M choose R minus K times N choose K. I have to establish this identity just using counting arguments, okay? So let us take a set T, and I am assuming that the number of elements in T is M, and take another set S, and the number of elements in S is N. हमने दो सेट ले लिए और S. Okay, T has M elements and S has N elements, right? Then so total number of ways to choose R elements from T union S कितने होंगे? If I have to choose R elements from the union of these two sets, M plus N choose R, right? M plus N is total number of elements in the union and choose R, right? So this is M plus N. Okay. Now another way to pick these R elements. So if I want to again choose, so to pick R elements from T union S, we can do in another way. What we do, we pick K elements from S and then R minus K elements from T. If I choose K elements from S, So this can be done in how many ways? N choose K. S has n elements. So I have to choose K elements, right? So this can be done in N choose K way. And what about this? T has how many elements? M. So this can be done in M choose R minus K ways, right? So basically I have to pick R elements from the union, which is M plus N elements, right? So another way is I pick K elements from set S and R minus K elements from T. So total number R elements pick up ho jayenge, right? So this can be done in how many ways? N choose K can be done in N choose K ways. This can be done in N choose K ways. And this can be done in M choose R minus K ways, right? So the total number of ways is the product rule, right? Product of these two for picking R elements. Basically, total number of ways will be to pick R elements from T union S is M plus N choose R on one side is equal to summation K is equal to 0 to R M choose R minus K times N choose K. So we are having the result. So that's all for permutation combination. And I have got a gift for you, right? So I think after this, basically we will be doing in the next class recurrence relations. तो ये ले लो अपनी gift, right? मजा आएगा, right?